Every map you have ever seen of our solar system is a fundamental lie. We carry a deep inaccuracy from our school days that suggests our neighborhood is a neat, tidy disk ending at the cold orbit of Neptune. But if you believe those maps, you are missing 99% of the real story. The truth is that the planets we know, Mercury, Earth, Jupiter, and Saturn, are not the main attraction of our cosmic home. They are merely a tiny, overcrowded center huddled near the fire of the sun. The real frontier of our solar system lies thousands of times further away in the dark, silent reaches of the abyss. We are currently living inside a colossal spherical prison made of ice. It is a structure so massive that it defines the absolute limit where the gravity of our star dictates the laws of nature. This is the Oort Cloud, and what science has discovered about this place is about to shatter your understanding of our place in the universe. To see the true face of our system, you must forget everything you know about that flat, saucer-shaped model, and prepare to enter a giant, hollow bubble that wraps around us in every single direction. While we often imagine the solar system as a flat disk, like a shallow plate where planets orbit on a single level, the Oort Cloud completely ignores this rule. It is not a ring or a belt, it is a perfect sphere. This structure envelops the sun in every direction above, below, and from all sides. We are, in fact, living inside a colossal hollow bubble of ice. The sheer scale of this bubble is almost impossible for the human mind to process. To describe these massive distances, astronomers use a measurement called the astronomical unit. One astronomical unit is the distance between the Earth and the Sun, which is roughly 150 million kilometers. For perspective, Neptune, the final planet in our neighborhood, is only 30 astronomical units away. Yet, the inner boundary of the Oort Cloud does not even begin until you reach 2,000 to 5,000 astronomical units from the Sun. From there, it extends into the dark void for 50,000 to 100,000 astronomical units. That distance is nearly halfway to Proxima Centauri, the very next star in our galaxy. Let us visualize this in a way that feels more human. Imagine a large dining table. If we shrunk everything down so that the Earth was only 1 inch away from the Sun, Pluto would sit about 1 yard away. Your entire known planetary system would fit right there on that table, but to reach the inner edge of the Oort Cloud, you would have to walk out of your house and travel hundreds of yards away. The outer boundary of this cloud would be more than 1.5 miles away. In this scale, the planets are just a few forgotten grains of dust at the center of a sphere that is miles wide. This megastructure is split into 2 distinct regions. The intersection is called the Hills Cloud, shaped like a thick donut, and it holds about 5 times more mass than the outer shell. As you move further into the void, you encounter the outer Oort Cloud, the true spherical cage that swallows the entire system. And what exists out there? These are not the dry rocks of the asteroid belt. Instead, we find pure, volatile, ice-frozen water, methane, ammonia, and carbon monoxide. These are primordial remnants, untouched debris from the birth of our solar system 4.5 billion years ago. They have remained in the absolute zero of deep space, nearly unchanged since the dawn of time. There is a major mistake people make when they try to visualize this place. Science fiction movies have conditioned us to expect a chaotic asteroid field, a thick storm of ice and rock where a pilot would need superhuman skill to navigate. But the reality is far more terrifying and vast. While the Oort Cloud contains trillions of icy objects, the volume of space they occupy is so immense that the average distance between 2 pieces of ice can be tens of millions of kilometers. If you stood on one of these frozen worlds, you would see nothing but absolute darkness and distant stars. Even our own sun would lose its warmth and size, appearing only as the brightest point of light in a cold, black sky. It is easy to assume this shell has always been there, sitting quietly at the edge of the system. However, the history of our solar system was violently chaotic. These trillions of icy bodies were actually born much closer to us, in the same region as the gas giants, billions of years ago, as Jupiter and Saturn migrated in a titanic gravitational dance. Their massive weight acted like a cosmic slingshot. They swept through the debris, violently ejecting billions of ice blocks into the abyss. Some escaped forever, wandering the galaxy as orphans. But others reached the absolute limit, where the sun's gravity still held a faint grip. Over eons, the gravity of neighboring stars molded this debris into the perfect sphere we see today. The Oort Cloud is, quite literally, the cosmic junkyard discarded by the giant planets in their youth. As we travel further into this frozen wasteland, a bizarre and haunting reality begins to take hold. When you stand on the surface of the Earth, the gravity of the sun is the undisputed master of your world. It is the invisible hand that keeps our planet spinning in a predictable, safe, and life-sustaining orbit. But at the outer reaches of the Oort Cloud, the sun begins to lose its throne. The further we drift into the dark, the more the sun's grip weakens, until its gravitational pull is so frail that it is no longer the only player on the cosmic field. This is the exact point where our solar system stops being an isolated island and begins to interact directly with the vastness of the entire galaxy. Scientists have a name for this haunting phenomenon. They call it the Galactic Tide. Just as the moon pulls on the oceans of the Earth to create the rhythmic rise and fall of our tides, the monstrous mass of the Milky Way itself exerts a titanic tidal force on the Oort Cloud. Imagine the dense disk of our galaxy and its supermassive core constantly reaching out through the void, tugging at these distant icy bodies. It is a silent, eternal game of tug-of-war between the dying embers of the sun's gravity and the overwhelming pull of the rest of the galaxy. This celestial struggle is actually what gives the Oort Cloud its unique shape. It is the very reason these objects do not fall back into a flat disk like the planets we know. The galactic tide pushes and pulls from the outside, holding the cloud in its perfect, spherical form. However, this equilibrium is dangerously fragile. The balance that keeps these trillions of ice blocks in place is not a wall of solid concrete. It is more like a thin, permeable membrane that is always ready to be disturbed. We like to think of our neighborhood as a static, unchanging place, but the stars in our galaxy are not standing still. They are rushing through the void at thousands of kilometers per second. And every once in a while, one of these massive travelers passes a little too close to our territory. When a neighboring star sails within a few light years of us, its gravity shakes the very cage we live in. It is a reminder that even in the deepest silence of space, we are never truly alone. And the stability of our home depends on a delicate dance between the sun and the stars beyond. The Oort Cloud is not a wall of concrete, nor is it a permanent, unmoving barrier. It is more like a thin, permeable membrane, a delicate veil that is constantly ready to be disturbed by the immense forces of the galaxy. We often think of space as a static place where everything stays in its lane, but the reality is far more dynamic and dangerous. The other stars in our galaxy are not standing still. They are rushing through the void at speeds of thousands of kilometers per second. And occasionally, these massive celestial travelers pass much too close to our own territory. When a star passes within a few light years of our system, its massive gravitational weight acts like a hand reaching out to shake the very cage we live in. This is not just a theoretical worry or a mathematical possibility. We know with absolute certainty that this is going to happen. Astronomers have already identified the culprit that will one day shatter our peace. It is a red dwarf star known as Gliese 710. Currently, this star is sitting roughly 60 light years away from us, appearing as nothing more than a faint speck in the distance. However, when scientists calculated its trajectory, they discovered something truly haunting. In a little over 1 million years, Gliese 710 is going to take a direct path through our neighborhood, passing straight through the Oort Cloud. It will reach a distance of a mere 13,000 astronomical units from our sun. To put that in perspective, this is not just a close call or a glancing blow. It is a metaphorical shot directly to the forehead of our protective icy shell. As this star tears through the cloud, its gravity will act like a plow, scattering millions of icy comets in every direction, while many of these objects will be flung out into the empty void of interstellar space. An unimaginable number will be pushed inward, falling toward the inner solar system and directly toward us. This event could trigger a relentless shower of comets that would last for millions of years, bombarding the planetary disk and reshaping the future of every world orbiting the Sun. It serves as a chilling proof that the Oort Cloud is not just a distant border. It is a living, breathing environment that links the fate of the Earth to the silent, grand movements of the stars far beyond our reach. Despite everything I've just told you, there's a deeply uncomfortable detail that haunts the world of astronomy. We have never actually seen the Oort Cloud, even with our most advanced technology and the incredible power of the Hubble and James Webb Space Telescopes. Humanity has never managed to take a single photograph of a confirmed object within this cloud. We have never tracked a specific rock as it orbits in that distant reach. You might wonder how science can so boldly claim it exists if we have never laid eyes on it. The problem is one of light and shadow. Objects in the Oort Cloud do not produce their own light. They only reflect the faint glow of the Sun. At a distance of 50,000 astronomical units, our Sun is nothing more than a weak, shivering point of light. Trying to find a dark ball of ice the size of a city at that brutal distance is like trying to spot a piece of coal against a black wall from 600 miles away. It is, for all intents and purposes, optically impossible. Then there's the issue of heat. You might think our infrared telescopes could detect their thermal signature, but those objects are far too cold. They sit just a few degrees above absolute zero, emitting almost no radiation. Their heat signature is completely lost in the cosmic background noise of the universe. It is as if the universe created the perfect storm of darkness, distance, and cold to hide this place from us forever. The discovery of the Oort Cloud did not come from a telescope, but from the pure mathematical genius of a Dutch astronomer named Jan Oort in 1950. He was struggling to understand the strange behavior of comets and noticed a bizarre pattern. There were two very different groups. The short-period comets, like the famous Halley's Comet, circle the Sun in less than 200 years and stay within the same flat plane as the planets. We knew those came from the Kuiper Belt just past Neptune. But then there were the anomalies long-period comets like Hale-Bopp or Comet West, which take thousands or even hundreds of thousands of years to complete a single orbit. Their paths were the smoking gun. They do not travel in a flat line like the planets. They drop in from the North Pole of the Sun or rise from the south. They appear from every possible three-dimensional angle in the sky. This randomness was the key. If they came from a flat ring, they would always arrive from the same side. Because they fall from every direction, the reservoir they call home must be a giant sphere that surrounds us completely. Finally, there was the problem of supply. Comets are fragile travelers. Every time they pass near the Sun, they melt, grow a tail, and lose mass until they eventually evaporate into nothing. If our solar system is over 4 billion years old, every original comet should have melted away long ago. The fact that we still see new comets falling into our sky today means there must be a massive cosmic freezer out there. It is a silent reservoir, holding billions of icy stones, waiting for a passing star to nudge a fresh batch toward us, to replace the ones that have been destroyed. Jan Oort proved the math, and the scientific world gave this invisible ghost his name. This brings us to one of the most famous symbols of human exploration, the Voyager 1 spacecraft. In the year 2012, the world stopped to celebrate a historic headline stating that Voyager 1 had officially left the solar system to become the first human object to enter interstellar space. It was an epic day for humanity, but technically, that headline created a massive illusion about our true progress. To understand where Voyager is today, you must realize that our system actually has two different frontiers. The first boundary is magnetic. The Sun constantly blows a storm of particles, known as the solar wind, which creates an invisible bubble called the heliosphere. This bubble protects us by pushing back the violent radiation from the rest of the galaxy. The limit where the breath of our Sun meets the pressure of the galaxy is called the heliopause. While it is true that Voyager 1 crossed the heliopause, and left the Sun's magnetic shield in 2012. Leaving a magnetic influence is not the same as escaping gravitational attraction. By the true laws of the cosmos, the solar system only ends where the gravity of the Sun can no longer hold on to anything. Voyager 1 is currently screaming through the void at 61,000 kilometers per hour, covering 17 kilometers every single second. To us, that speed is staggering, but compared to the vastness of the Oort Cloud, the probe is practically standing still. It will not even reach the inner boundary of this cloud until the 24th century. The silent tragedy of this journey is that by the decade of the 2030, the plutonium heart of the probe will stop beating. It will fall silent, continuing its journey as a dead piece of metal for 30,000 years before it finally crosses the backyard of our own star. This reveals the great paradox of our future. The barrier holding us back is not a wall of bricks, but the emptiness of the void itself. Crossing the Oort Cloud today is an engineering nightmare with no islands for refueling. The distance of 100,000 astronomical units acts as a natural quarantine for our species. For our current technology, this is not a trip. It is a geological era. We are, for now, a species isolated on a tiny island. The Oort Cloud is both our cradle and our cage, protecting the remnants of our creation while imposing a limit that tells us we are still too small to leave home. Yet, there is a profound beauty in this isolation. Thousands of years from now, when our cities have crumbled and our history has been rewritten, the tiny Voyager 1 will still be out there. It will remain as a human fossil floating in the absolute dark, an unbreakable monument to our curiosity. It serves as a reminder to the universe that even when faced with an impassable abyss, we were never afraid to look toward the frontier where our home disappears. The universe makes us seem small, but it is our drive to understand it that truly makes us giants. If this journey through the dark has changed the way you look at the stars, the best way to support us is by subscribing to the channel. Please leave a like and share your thoughts in the comments. What do you believe is still hidden in the shadows of the Oort Cloud? Thank you for joining us on this journey to the most distant frontier. We will see you on the next voyage.